Hey everyone, welcome back to the channel. Today we're unpacking a term you're probably hearing more and more, Agentic AI. If you've wondered what an autonomous AI agent is, how it's different from a standard model, or why it matters for products and safety, this video is for you. Over the next 7 minutes, we'll break it down in plain language, show real-world examples, and give you a practical sense of how to build and evaluate agentic systems. Stick around to the end for resources and a quick demo idea you can try yourself. First, what do we mean by agentic? In short, agentic AI refers to systems that act autonomously toward goals. Instead of just generating text or predictions on demand, an agentic system plans, makes decisions, and takes sequential actions in an environment to achieve objectives. Think of an agent as a combination of perception, reasoning, planning, and action. It senses the world, decides what to do next, and executes actions that change the world or its internal state. That's the core idea: agency, autonomy, and goal-directed behavior. How is an agent different from a standard AI model? A typical language model responds to prompts. It's reactive and stateless by design. An agent, by contrast, maintains goals and a state, may take multiple steps across time, and can interact with external tools or environments, like databases, APIs, or hardware. So while both can use similar underlying components like neural networks, the architecture, objectives, and evaluation change. Agents are judged by task completion, robustness, and long-term behavior, not just immediate accuracy. Let's break down the key components you'll find in most agentic systems. Number 1, a goal representation or utility function that defines success. Number 2, a planner or policy that chooses actions. Number 3, perception modules to process inputs, such as language or sensor data. Number 4, action interfaces that let the agent affect the world, APIs, UIs, hardware. And number 5, memory or state to remember context across steps. Finally, evaluation and safety filters are often layered in to constrain behavior. Together, these components enable purposeful, sequential behavior. On the technical side, agentic AI commonly combines several techniques. Reinforcement learning provides a mathematical framework for learning from trial and error with rewards. Planning algorithms like MCTS or heuristic search create multi-step plans. Large language models can be used for reasoning, translation, or natural user interfaces. Tool use is enabled by connectors that translate abstract actions into concrete API calls. Memory systems, often vector databases or episodic stores, maintain context. The orchestrator or controller coordinates these pieces, deciding when to plan, call a tool, or consult memory. What does agentic AI look like in the wild? A few examples. Autonomous trading agents that monitor markets and place orders based on strategy. Customer support agents that triage tickets and escalate or resolve issues through integrations. Robotic warehouse pickers that plan routes and manipulate objects. And personal assistants that schedule meetings, book flights, and proactively follow up. Even multi-agent simulations for logistics or traffic optimization are agentic systems coordinating multiple goal-directed entities. Let's walk through a mini demo concept you can try locally. Imagine an agent that automates monthly expense reporting. It needs to fetch receipts from email, extract amounts, categorize expenses, generate a spreadsheet, and submit to a finance system. Step 1, connect Mail API and PDF parser. Step 2, use an LLM to extract structured data from text or receipts. Step 3, plan batching and deduplication. Step 4, write to a spreadsheet via API and file a submission. Each step is a callable action, and the agent loops until the task is complete. I'll link resources and pseudocode in the description. What tools help you build agentic AI? There are several categories: orchestration frameworks to manage steps and tool calls, vector databases for memory, LLM providers for reasoning, RL libraries for learning-based agents, and SDKs to integrate with external APIs. Examples include LangChain-style orchestrators, OpenAI and other LLM APIs, Pinecone or Milvus for embeddings, stable baselines or RLlib for reinforcement learning, and custom connectors to services like Google Workspace or Slack. Pick components based on your requirements for latency, interpretability, and safety. Agentic AI brings big benefits: automation of complex workflows, proactive problem solving, and the ability to coordinate multi-step tasks that were historically manual. But there are limitations: brittleness in unforeseen situations, difficulty specifying correct reward or goal functions, potential for unexpected side effects, and higher engineering complexity. Performance depends heavily on the quality of sensors, tools, and evaluation criteria. So it's powerful, but not a magic bullet. Real-world deployments require careful testing and monitoring. We can't skip safety. Agentic systems can take actions with real consequences, so ethics and controls are essential. Common safety layers include action filters to block harmful outputs, human-in-the-loop checkpoints for high-risk decisions, constrained tool permissions, monitoring and auditing logs, and transparent goal specification. There are also governance questions. Who owns agent actions? How do you ensure accountability? And how do you prevent misuse? Building agentic AI responsibly means designing limits and clear audit trails from day one. Looking ahead, agentic AI will likely become more capable and more integrated into everyday tools. We may see more multi-agent collaboration, agents that can learn from fewer examples, and stronger tool use capabilities. At the same time, expect ongoing debates around regulation, standards for testing agent behavior, and new patterns for human-agent collaboration. The exciting part is the space for innovation, building interfaces and governance that make agency useful and safe. All right, quick recap. Agentic AI are autonomous, goal-driven systems that perceive, plan, and act. They combine planners, models, memories, and tool interfaces to solve multi-step problems. They're powerful for automation and coordination, but bring complexity and safety responsibilities. If you want to get started, try a small, well-scoped agent like the expense report example. Prioritize testing and add guardrails. If you found this useful, hit like. Subscribe for more technical explainers and check the description for links, resources, and starter code. Drop questions or demo ideas in the comments. I read them and often build community-driven follow-ups. Thanks for watching. Follow me on Twitter and GitHub for code and updates. Check the pinned comments and description for timestamps, links to the repo, and extra reading. See you in the next video where we'll prototype a tiny agent live. Bye for now.